Alright, so we'll talk about sketching piecewise functions. Now, for you to be able to sketch a piecewise function, you need to know how to sketch radicals, how to sketch basically all types of functions, rational functions, quadratic functions, modulus functions, because a piecewise function can be given in any one of those forms. Let's say we've been given f of x, which is equal to, let's say they say x. Now, this one is valid for values of x which are less than 1, and say x minus 2 now when x is greater than or equal to 1. You want to sketch this function. How do you do it? So, how can you sketch this function? So first thing first is you just need to have a simple understanding of how to write these functions here. So the critical points that you look at are these values here. So you're talking about the reference point is x is equal to 1. So that is the main point. So say here is your 1. Now what you are going to do is you are going to start putting in this function. Where there is x, so it will become y is equal to x. So you just get this. This is your y, or f of x is equal to x. And it is only going to be equal to x when x is smaller than 1. So meaning that the only x values that is going to be valid for this one here are values of x less than 1. Let's start with a 1 itself. Where there is x, let's put 1. So you find that y is also going to be equal to 1. But remember, this is less than. We aren't including 1 itself. So we're going to put an open circle there. And then remember, we're talking about values of x less than 1. We'll get another number which is less than 1. An example that we can give is a 0. Let's put where there is x. So it will be y will also be 0. Okay. And then let's say x is negative 1, because negative 1 is also less than 1. What will be the value of y if we substitute here? Y will also be equal to a negative 1. So you see how the function is going. The function will continue to go down like this. It's a straight line. Now for values of x greater than 1, the function that will apply is x minus 1. So starting with 1 itself, let's put where there is x, we substitute a 1. So it will become 1 minus 2. That will give us negative 1. So when x is 1, y is going to be equal to negative 1. But this one I'll put a dot y because I'm including also 1. Remember, this one is only valid for values of for functions or parts of the function greater than 1. So we'll get a number greater than 1. And next one is a 2. So that will become x minus 2. And in this case, we're talking about 2. So it will become 2 minus 2. That is going to give us a 0. So it will be this point. Another one we can get is a 3. We substitute where there is x. 3 minus 2, that will give us a 1. So it will be at this point. So the function will continue to go like that. So this function is going to be a straight line like that. So it's supposed to be a coordinate there. So this is the graph of this function, and this is how you're supposed to sketch this function here. Okay. And then we can look at another example. Let's say we've been told that y, or f of x, let me use the same f of x because it's a function. F of x is equal to, it's a piecewise function. On top we have got square root of x, and this is going to be for x values greater than, we start with less than a 2, and then let's say it is x squared for values of x greater than or equal to a 2. So how do you sketch this function? First thing first, also write your x or y plane. Now for this one, the reference point is actually going to be a 2 because we're talking about values of x greater than 2 and less than 2. But for values of x less than 2, the function that is applying is square root of x. You need to know that for a radical function, square root of x looks like this. And then square root of negative x will look like this. Now if you have got a negative inside, so what does this mean anyway? That's what we need to understand. So if we are talking about y is equal to square root of x, look at the number in front. X is positive, meaning that the function is going to be going towards the positive values of x. Look at the number in front of the function. It is also positive, meaning that the function will be going towards positive values of y. That is why this function is going forward and up like that. But if it is y is equal to negative square root of x is still positive, so it means the function will be going in the positive x, but the function is negative, so the function will be going towards negative values of y. So that's why this function will be moving like this. If we had y is equal to negative square root of x, and then there's also a negative inside, this means that x is negative, so the function will be going towards negative values of x. Y is also negative, the function will be going towards negative values of y. So this function is going to be moving like this. So a radical function always like goes more following the x-axis. You can see the function is not going like this, it's going like this, because what goes following the y-axis is a quadratic, not a radical. So now we can sketch this function. Now here we've been told this is the square root of x. We know that square root of x, the function is supposed to go like this. This is how the function is supposed to move. But remember, this one, it's only valid for values of x greater than, less than 2, I mean. Oh, this is only for less than 2, remember. What does that mean? We are only talking about from 2 going in this direction. So meaning that for this function, we'll not be able to include that part, we are going to remove it. So it will just be from here going in this direction up to 0 here. Now when x is 2, what will be the value for y? We need to find that. So just put here to be square root, put where there is x to be square root of 2, so meaning that y is going to be root 2. So this is the first function for values of x less than a 2. And then for values of x greater than or equal to 2, what is applying is a quadratic. And a quadratic, how do you sketch it? A quadratic goes like this, to go like this, and then it is going to go like that. Now remember, this function is going to be only valid for values of x greater than or equal to 2, meaning that just from 2 going up. So then how do you sketch? The first thing is find out when x is 2, what will be the y value. So when x is 2, put where there is x, it will be x squared, which is a 4. And 4 is going to be somewhere on top there, so that is going to be 2,4. But this one I'm going to shade because x is being included. And the function will continue going up like that. Because remember, it was supposed to be like coming down like this, and then come like this, and then continue like that. But when it start from this point and then go up, that is the sketch of that function. Do not write the one which I've written in dotted lines. Okay, so that is how you get to sketch this one. Let's say we've been asked to sketch a function f of x, and that is equal to, say we have got x squared plus 1, and this is going to be for x is less than negative 2. Okay, and then let's say the function is equal to 2 when negative 2 is less than or equal to x, which is less than, let's say, 3, and then the function is square root of x plus 2 with a negative there, and this for x is greater than or equal to 3. Now I want to sketch this function. How do you go about it? So the first thing, again, also look at your critical points. Our critical points is a negative 2 and a 3. Those are the only values that we have as a range. So I'm going to put negative 2 here. I'm going to put a 3 there. For values of x less than negative 2, the function that is applying is x squared plus a 1. X squared plus a 1, what does that mean? X squared plus 1. This function, to a quadratic, normally goes like this. Now, because of this plus 1 that you've seen, it means that the function will not pass at the point 0, 0, to come now and pass at 1 and go like this. Okay, so that is how the function is supposed to go. But this is only valid for values of x less than negative 2. So if x is negative 2 here, what will be the value for y? Come and put here negative 2 squared is a 4 plus 1, that is going to be a 5. So this is a 5 here. So meaning that this function is going to be, remember it was supposed to be coming like this, and then come and cut at 1 and then continue, but will not write this portion that is greater than negative 2. So it's just this region. And then between negative 2 and 3, the function is giving us what? A 2. That is a 2 that you can see there. So as long as we are between negative 2 and 3, the function will always be a 2. Okay, now just something that I've not included here. So here, like this function is supposed to be going in this way up. Now I've put an open circle here because we are not including 2, as you can see from this function. Now as long as we are between negative 2 and 3, our function is giving us 2. So 2 is going to be somewhere here. And we are including negative 2, as we can see, but we are not including 3. So 3, we are going to put an open circle. So as long as we are between these, the function is always giving us a 2. So it's supposed to go like that. And then when x is greater than or equal to 3, the function is negative square root of x plus 2. Now, negative square root of x plus 2, how does that mean? Just the negative itself inside the root, just equate x plus 2 to 0. That will give you that x is equal to negative 2. So x is equal to negative 2. Negative 2 is going to be here. So this is where the function is going to start. But look at x inside the root, it's positive, so meaning that the function is going to be going in this direction. But y is negative, meaning that the function is going to be going down. So this function is actually going to be going in this direction like this. That's how it's supposed to be moving. But then this function, we're only interested in for values of x greater than or equal to 3. So let's say 3 is here. So we're only going to start from here, writing only this part. So now my interest is what will be the y value when x is a 3. So that will be 3 plus 2. That is going to be 5. So that will be negative square root of 5. And negative square root of 5 is 2 point something. So this is going to be the coordinate here. I'm shading it because it's being included. Remember, this function is supposed to be moving like this. So just write this part like this. Don't include the one I've put in shaded lines. So this is how you get to sketch this function. Let's include another one. Say we are talking about f of x is equal to, say you have been given x plus 1. This is when x is less than a negative 1. So we've been given, okay, let's say we've been given also 2x squared. This is when x is between negative 1 and let's say a 3. And so we've been given absolute value of x plus 2. And this is when x is greater than or equal to 3. So how do you sketch this function? So first thing first, start with the value or the first function. For x is great, this I was supposed to say less than, not greater than. For x is less than negative 1. So negative 1 is here. The function that is applying is this one. So start with negative 1 itself. Where there is x, put negative 1. So find that y is going to be 0. But do not include 0. I'll put an open circle. Why? Because this is just lesser than. And then get any number less than negative 1. A negative 2, put here. Negative 2 plus 1. Okay. Negative 2 plus 1. That is going to be negative 1. In case you have got a question, you can simply open your mic and be able to ask.
Okay. Okay. No, that the last part where it's very hard for me. Any part I talked that redefine a function. How to redefine it? Then question over me. This was the question. Now and I don't know how to redefine it.
Okay, I'll give an example of that one.
Okay, thank you.
So this is a straight line. So what I've written, 2 points are enough for you to to write the equation of a straight line. I mean the graph. So just join these 2 points with a straight line. So we're supposed to pass through this point and go and pass through here. It should be a straight line. Okay, like that. Now between negative 1 and 3, when x is negative 1 and when it is positive 3, the function is giving us 2x squared. Now 2x squared, this function is supposed to come and pass on the middle. As long as you have got x squared, the function is supposed to pass on the middle. This number in front is only changing the gradient of the function, meaning that the line is becoming more steeper. Okay, so we know that that's how a quadratic looks like. But then, because we are talking about between negative 1 and 3, start, if your x is negative 1, come where there is x, you put negative 1. So that will be 2 times negative 1 squared. That is going to be 2 times negative 1. Negative 1 squared is a 1. 1 times 2 is a 2. So I'm finding that x is going to, y is going to be equal to 2. But because we're including negative 1, so I'm going to shade this point. And when x is 3, we'll substitute here again. That will be 2 times 3 squared. 3 squared is a 9. 9 times 2 is 18. 18 will be somewhere very much on top. Let me just say it's here. This is 3 comma 18. So this function is supposed to move like this, passes here, and then it goes all the way up to this point. And then for values of x greater than or equal to 3, this is the function that we are using. Now when you are sketching the absolute value of x plus 2, simply equate what is inside the bar to 0. So that will give you that x is negative 2. And then this is your negative 2 here. Okay. Now that negative 2, what the function will do is, because it's a positive here, to be going up like this. That's how it's going to be going. But we are only interested in starting from where 3 is, somewhere here. So what would be the y value at that point? So put here 3 plus 2. That is going to give us a 5. Say 5 is somewhere here. So it's going to be here, which is 3 comma 5. And then just continue the line going up, because that's how it's supposed to move. You can see how it is in this region. So that is how you can sketch this function. So the sketch of modular, piecewise functions is very, very easy. Okay, let's try one more example. Let's say you have been given f of x is equal to the absolute value of x minus 1 minus the absolute value of x plus 2. You want to sketch this function. Now this is a modulus function, but the only way you can sketch is when you write it as a piecewise function. And writing a modulus as a piecewise function is known as redefining the function. So first thing is you need to redefine this function. But how do you redefine? First, get this value here equated to 0. X minus 1 is equal to 0. You're going to find that x is equal to positive 1. Get this value equated to 0. You're going to find that x is equal to negative 2. When this happens, now get these two values. The smallest is negative 2 and then a 1. Write those factors that you had equated to 0. The first factor is x minus 1. Second one is x plus 2. Now, when we equated x minus 1 to 0, we found 1. So if I get any number above 1, I put where there is x. For example, a 2, it will be positive. Immediately I cross 1, it will be negative. You can try any number less than 1, you put where there is x in this function. When we equated x plus 2 to 0, we found negative 2. If I get any number above negative 2, for example, a negative 1, negative 1 plus 2 is positive. So as long as we are above negative 2 to be positive, immediately we cross negative 2, it will be negative. For example, get a negative 3 plus 2 is negative. So now what I'm going to do is I'm going to write this function f of x is equal to, I'll write it, but I'll not include the absolute function. So I'll write it as x minus 1 minus x plus 2. I'll write it 3 times x minus 1 minus x plus 2. I'll write again x minus 1 minus x plus 2. So if you look at this function, the first values we want to talk about are values of x less than negative 2. So say x is less than negative 2. I can even say less than or equal to negative 2. You can see both functions are negative. So to these two functions, I'm going to attach a negative in front. And then between negative 2 and 1. So I'm going to say negative 2 is less than x, which is less than 1. You can see x minus 1 is negative. So for x minus 1, put a negative there. X plus 2 is positive. So for x plus 2, put a positive here. And then you also have values of x greater than or equal to 1. So say x is greater than or equal to 1. You can see that both functions are positive. So put a positive here, put a positive here. So this is what you want to simplify. If you just simplify this, then you have redefined the function. So we say f of x is equal to, so if you distribute this negative with just what is on top here, we are going to have negative x plus 1. Now these two negatives will give us a positive, and that positive times what is inside the bracket, that will be x plus 2. So you see that negative x and positive x will cancel, so just remain with 1 plus 2, and that is going to give us a 3. So the function is going to be 3 for x is less than or equal to negative 2. And then for the one down, we'll distribute this negative to what is inside. We're going to have negative x plus 1. And then the negative here also times positive is negative, and distribute with what is inside. So that will be negative x minus 2. Negative x minus x, that is negative 2x. 1 minus 2 is a negative 1. And this is going to be between negative 2 and 1. And then the last one, now distribute the positive, that will just be x minus 1. This is a negative, distribute, that will be negative x plus 2. This will cancel with this, so this will just be negative 1 plus 2. That is going to give us a positive 1. And this is for x is greater than or equal to 1. Now that we have redefined our function, we can now be able to sketch it. Okay. Now, sketching at this point is just the same as the sketching that we have been doing all this while. So that is the only problem when you are sketching a modulus function in this form is just redefining. And what we have done at this point is redefine the function. So sketching is going to be very direct and easy. So the first thing that we are going to do is get to write your number line, or your Cartesian plane, sorry, not a number line. Here is your x axis, here is your y axis. Okay, and then the next thing that we are going to do is, as long as we are less than negative 2, less than negative 2, the function is always giving us a 3. So as long as we are less than negative 2, the function will always be a 3, always be a 3. So it will continue like that. Now between negative 2 and 1, the function is giving us negative 2x minus 1. So what you do is just get negative 2, you put where there is x. So that is going to be negative 2 times negative 2 minus 1. I've gotten this value. What is the y value we are going to find? This is going to be 4 minus a 3, minus 1. That is going to be a 3. So it will give us this same point here. And then when x is, get the last value, which is a 1. So that will become negative 2 times 1 minus 1. So give us negative 3. So we have got 1 comma negative 3, which is here. And then just connect these 2 points with a straight line. Like that. And what else will be necessary is for you to find these intercepts. These 2 points, the intercepts. So when x is 0, y is going to be equal to negative 1. Also find when y is 0. All I'm doing is I'm putting where there is x, I'll put 0 there. So y is negative 1. And then y is equal to negative 2x minus 1. How about when y is 0? What will be x? Take 1 the other side. So it will be 1 is equal to negative 2x. So x will be negative 1 over 2. So actually this is negative 1 over 2, and this is a negative 1 here, the y value. And then as long as we are greater than or equal to 1, the y value is a 1. And 1 is going to be somewhere here. As long as we are greater than, for x, as long as x is greater than or equal to 1, y will always be giving us 1. So it will be going like straight, giving us 1 in this direction like this. So this is a sketch of this function, and this is how you get to sketch piecewise functions.